Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Cubane, C8H8, has a cubic carbon skeleton. To determine the number of bond cleavages needed to convert a cyclic or polycyclic structure into a non-cyclic, acyclic tree skeleton, we use the circuit rank, cyclomatic number, formula mu is equal to EV plus 1, where E is the number of edges, bonds, in the carbon skeleton and V is the number of vertices, carbon atoms, assuming a connected graph. Moving on to the next step. Identify the graph parameters of cubane's carbon skeleton. Cubane has 8 carbon atoms, vertices, V is equal to 8. A cube has 12 edges, bonds, E is equal to 12. Moving on to the next step. Apply the cyclomatic number formula. Mu is equal to E, V plus 1 is equal to 12 to 8 plus 1 is equal to 5. And for the final step, interpret the result. The cyclomatic number mu is equal to 5 means cubane has 5 independent rings, ring systems. To convert a polycyclic structure into a non-cyclic, acyclic, skeleton, you must break exactly as many bonds as there are independent rings, i.e., 5 bond cleavages. Why other options fail? A. Too few, breaking only 2 bonds would leave 3 rings intact. B. 3. Too few, breaking 3 bonds would leave 2 rings intact. C. 4. Too few, breaking 4 bonds would leave 1 ring intact, still cyclic. D. 5. Correct, breaking 5 bonds reduces the cyclomatic number to 0, yielding a fully acyclic, non-cyclic, skeleton. Therefore, the correct answer is D. Therefore, the correct answer is option D.